There are many beautiful islands around the world, uniqueness in terms of biological diversity. Plastics-made islands, garbage patches. Plastic persist at the ocean surface as they make their way offshore, transported by converting currents and finally accumulating in the path. Once the plastics enter the gyre, they are unlikely to leave the area until they degrade into smaller microplastics under the effects of sun, waves, and marine life. As more and more plastics are discarded into the environment, size of garbage patches increase rapidly. Globally 5 to 13 million tons of plastics end up in the oceans every year. Plastic Island covers an estimated surface area of 1.6 million square kilometers, 3 times the size of France. We are recycling the plastics, but why does it happen again? The methods are not enough efficient to eliminate them from the environment. Too polluted plastic wastes and insufficient recycled plastics have the same destiny: landfill and discard in the ocean. The best solution has been made till now, is exporting extra polluted plastic waste, and rest of them physically are converting to downgraded plastics. Polluted earth, ocean, atmosphere, creatures, human, all are in result of inefficient methods of recycling and producing downgraded plastics. There is no differences between being landfill in ocean or ground and physical recycling. Both scenarios show that they will remain in the environment at least 700 years. What is the problem? First of all, let's see what is happening in the current life cycle of PET, from producing to recycling. 1. Extracting oil and gas. 2. Producing xylene from oil and gas in petrochemical plants. 3. Processing xylene to PTA in further petrochemical plant. 4. Producing PET from PTA in simple polymerization process. 5. After usage of PET bottle, throw it away. 6. Collecting PET waste by waste collectors, companies or municipalities. 7. 3 different processes will be happened. 7.1 Physical recycling of PET to downgrade PET and finally disposed to the landfills after 1 or 2 times of recycling. 7.2 Incineration in order to produce electricity. 7.3 Hard to recycle and contaminated PET disposed to the landfills. What is the solution? Creating a new value chain, breaking the current chain of recycling to prevent increasing the pollution of environment by upcycling plastic waste to raw material with best quality. We put PET waste bottle with caps, label and all kind of contamination in reactor A without any washing. After adding zero PET formula, solvent, and catalyst, first reaction start, and after some hours we filter first output and start second step in reactor B with adding second zero PET formula. After that outlet filtered again and other type of plastic and all contamination will be removed. The solution residue of reactor B pour into reactor C, and after adding sediment mixture, 3 product will be achieved. Main product is PTA and side products is 1 salt and 1 liquid that we can use either in the zero PET process or can be sold in the market for a value. We are going to preserve our planet and stop damaging it from microplastics. If we will be more careful about the process of producing and recycling the plastics, we can save our beautiful islands and their creatures.
I'm Sasan Momtazi, founder and CTO of the company, Recyclinnova, and also with us is Luca, CEO of the company, that we start together. In Recyclinnova, our vision is to tackle 2 major problems of modern age: plastic downgrading and plastic landfill. But today we are speaking about textile recycling in Europe's circular economy. Regarding to the European Commission report, 5 to 13 million tons of plastic is wasted after being used once and polluted the environment. And among them, 7.7% is polyester. Also, regarding to the European Parliament report, every European consumes 26 kilograms of textile per year and discard 11 kilograms of textile per year. And if we consider 446 million people living in Europe, we are producing 4.9 million tons of textile as a waste. And among them, normally until 2018, 87% goes to the incineration and landfill, and only 1% of them will be converted to textile again. And other portion will be exported to other countries. But what is the problem? The problem comes back to the linear value chain of textile. As you can see, the textile market is highly globalized, and millions of producers and billions of consumers are involved in this linear chain. But as you can see, raw material will be converted to fiber production and textile production, transport, and consumption. And after that, what happened? Reuse, landfill, or energy recovery. But with help of chemical recycling, we are able to convert textile waste, include 70% polyester, to purified terephthalic acid, or PTA. And after that, this key element can be converted to polyester virgin fiber again and again. Looking in climate change pressure, for processing each ton of textile, we should consume and produce 15 to 35 tons of CO2. And with this method, we can prevent to using oil derivative. Textile waste is composed by natural and synthetic fiber, can be categorized into the post-consumer waste and industrial waste that is normally produced through manufacturing. Today, 60% of the textile is synthetic fiber, and polyester is the most commonly used fiber that produced from carbon-intensive process, requiring more than 70 million barrels of oil each year. Our solution is based on chemoselective process, and as you can see, when zero PET process, in our process we use different kind of feed, like the feed with 91% polyester, 84% polyester, and 16% elastine. And after some step, depolymerization will be started, and as you can see in this picture, elastine will be remain in the surface, and the polymerized polyester will be deposited, and we can easily remove it. The main product is PTA, or purified terephthalic acid, and we can remove elastine with a simple separation process. I just want to ask to Mr. Loise to continue our presentation.
Thank you. Yes, we can go to the next slide, and it's about what we are currently running is a small pilot around 80 kilograms per day, operating in a batch mode, and we normally process the feed, and in the picture you can see the plastics, PET coming from packaging in those cases, and we can process it from flakes without any washing. And this is also one of the best advantage of the technology. As Sasan said before, is chemoselective. We can process a very high contaminated plastics up to 20% without any problems. For example, we talk about packaging, and we can process it together with caps and labels, so it means together with other polymers. And Sasan also spoke about the elastane, which is normally included and in the textile, the polyester textile. And with this process, after several steps, we can separate the contamination, the unreacted polymer. Doesn't take, do not take part into the reaction, and the main product is a very pure terephthalic acid as powder, which is shown in the picture on the right side, and two other side products are an inorganic salt and an industrial solvent. All of the product are commodities, and of course used larger use in the industry, and specifically for the PTA. We know it's a very huge market, and you can use it. And we can go to the next slide, Sasan. Of course, to get again virgin PET on polyester again, almost 70% of the worldwide PTA produces, of course, for these markets. So for the fiber market, textile, and 20% is for the packaging, and remaining percent is for film. We know that PTA is also used in the pharmaceutical industry, or for the fillers and other segments in the industry. What we can see here, and what's the goal of this technology, is just to reduce the exploitation of the oil on the resources where we know the PTA normally come from, to feed the entire cycle. And we can, after, try to avoid finally the downgrading of the plastic that which normally occur for the physical recycler, or the burning the waste as energy recover. And we can bypass these steps and just close the loop, going back to the raw materials, the valuable chemicals, to produce again the textile, the fibers, or the packaging. And of course, one of the most problem can also be avoided, and Sasan already mentioned it, is the landfilling, which is still a threat for our environment. It's crazy to see, and sometimes the statistics, and also in the most developed country and area in the world, for example, the United States, also still produce kind of 25 million tons per year of plastic, which is landfilled. And in Europe, it's a little bit better, but it's still too high. It's around 6 million still. And of course, this is the goal, but there are a lot of obstacles. And one of probably the best solution would be increase the collaboration throughout the segment and throughout the supply chain to mix the producer and the consumer needs, and at the same time probably and help from the policies is also needed, because it's very hard to compete at price level with the product coming from the oil, of course, because it's still the market is still dominated from this feed. We can go to the next slide, and here is, as mentioned before, the supply chain where we are heading to, and the PTA producers. One of the biggest site in Europe is located in Portugal and operated by Adlan, and the PET producers, of course, is Nova PET in Spain, and the waste management that can easily and supply all the process operating, in our case is chemical process, as Sasan said, and all physical recycling companies that should try to that at the moment still dominate the market of the recycling, but they're just moving, and they're thinking how to solve the downgrading problem that is one of the most challenge for them regarding the PET specifically. And we can go to the next slide, and here the kind of business model and how Zero PET technology is trying to reach the market. We patented the technology 2 years ago, and the Zero PET technology owned by Recyclinnova can either license the technology to the clients that manage the plastics to produce or sell the valuable chemical products and get the revenues from sales, selling it to the final clients. As I said, all the products are commodities, and are largely used all around the world. Sasan already introduced, and we can go to the final slide, and co-founder of this company, and me as CEO, and we are sorry. And we are.
It's the last slide, Luca.
It's the last slide. Sorry, I thought we could also one with the presentation.
But you can introduce by yourself.
Sure, indeed, and that's perfect. We are currently trying to join the Pilots campus, and we hope to do it as soon as possible to try to integrate also this technology with other chemical recycling, because it's very, very important to specifically, I think, in the chemical recycling, to integrate different kind of technology, the glycolysis, pyrolysis, and hydrolysis, because all of them have something that is not, I mean, some weakness, and the only way to increase the efficiency of recycling and chemical recycling is to try to integrate into a very into a larger network all of these technologies, in order to use something that one technology cannot process as feed of the other one. And this is, I think, of course, possible specifically through our technology and pyrolysis and glycolysis as well. Okay.